Hello, and welcome to the first block of sessions of UniteToFight 2024. I'm Lauren Goshen. I'm here as an ally for friends suffering with long COVID, and I'll be the moderator for this block of sessions. During this block, we will hear from two presenters, Professor Daniel Altmann and Johan van Vijenberg. Each speaker will give a 20-minute presentation, followed by 10 minutes of question and answer. During the presentations and Q&A, you'll have the opportunity to submit questions to each speaker and to upvote the questions. I will then present the most upvoted questions during Q&A. At the end, the block will conclude with a video contribution from Anil van der Zee, a professional dancer who was diagnosed with severe ME. So without further ado, I am pleased to introduce our first speaker, Daniel Altmann, Professor of Immunology in the Faculty of Medicine at Imperial College in London, who will present on the immunology of long COVID. Welcome, Professor Altmann.
Thank you very much. I hope you're seeing my slides okay. Yeah, so I'm Danny Altmann. I'm Professor of Immunology at Imperial College London. And I've spent my whole adult life really involved in research on kind of the interface between autoimmunity and infectious disease, particularly viral infectious disease. And I've certainly been involved with long COVID from the very earliest days of discussions about it in the pandemic. And so what I wanted to do was give you my overview of where I think we stand on immune mechanism, burden, and unmet need. Sorry, I'm just having trouble moving my slides on. If we think about where we've got to on long COVID, it's been a really, rapid progression, hasn't it? And I'm talking here about medical research on long COVID. So that little screen grab that I've shown you at the bottom is a screen grab of papers on PubMed about long COVID year by year. So we've gone from a standing start to naming a new condition, and obviously that was a patient-coined and patient-led description, almost unique in my career as a phenomenon. And we've gone from a standing start to more than 40,000 publications of variable quality, some of them terribly good, some of them less so. I'd argue that we know an awful lot about this condition now, and if we could knock heads together and achieve some consensus, we could be doing much, much better than we are at the moment. Because as we've already heard in a number of the presentations, and I'm sure we'll continue to hear over the next few days, this is a global challenge, a major new global challenge. And if we could only amass the data, including the health economics data, we're talking very often about 3% or more of the workforce affected. And if that doesn't speak to the, if that doesn't touch the humanity and compassion of our policymakers, it ought to touch their economic interests and, move towards some kind of ability to address the problem. So this is a paper that that I wrote right at the beginning together with Rosemary Boyton when we first started to think what on earth long COVID could be, and I think it was quite prescient. Many of the points we made way back at the beginning still hold sway, that we need to work out how to shift the agenda along from the observational to the interventional and do something for people who've often lost their lives and their livelihoods and their normality to this new disability. I should say that the focus of my research and my research funding has necessarily been on long COVID, but I regard many of the kind of research imperatives and societal imperatives as being kind of interchangeable with discussion of ME/CFS, and I think that they inform each other. And as we move forward, we need to use one condition to inform the other, because there's absolute need for cross hybridization there, teaching from one to the other. Some of the data I'll show comes from my perspective as a researcher living in England in the UK. But I think it's generalizable. In the UK, one of the things we did benefit from was quite good data, national data, surveillance data from the ONS, the Office for National Statistics, and it it paints a very bleak story. And for those who ever sought to to minimize or gaslight long COVID sufferers as being, the privileged or work shy or, stay at homes. This really is a profound disease that has hit the most deprived in society, mainly because those are the ones who were least facilitated to sidestep the most brutal aspects of the initial pandemic. And to emphasize again, although I speak with some of our data from a UK perspective, this is absolutely a global problem. So COVID-19 has infected people across the globe, and the kind of numbers we cite, perhaps 10% with long COVID as a kind of baseline level from people who were infected in the early waves in the pre-vaccination phase, reducing that risk as we've moved along to so-called milder variants and a vaccinated population to perhaps a risk of 3 or 4% of long COVID today. That makes a huge cumulative burden globally. That's true of every country that I'm aware of in the world that has had COVID-19. So, we all in this audience know a lot about the core symptoms and the many, many publications on this. And between us, we have a kind of core set, don't we, of symptoms that are intrinsic to the characterization of long COVID, and obviously many of those shared with ME/CFS. The question of how long does it last may seem obvious to you, but this version, taken from again the UK ONS data set, but I think it's non-trivial and non-obvious to remind people that 1/3 of those with long COVID have now had it for over 3 years, and some do gradually recover, but a significant minority don't, which means that while one might intuitively have expected the the long COVID graph, if you like, to be coming down at this stage, it's not. It's still creeping up. The reason it's still creeping up is because we've got that kind of that core of true long hauler, more than 3-year long COVID people who aren't getting better, and on top of that, we're accruing an ever larger caseload of new cases, even from the so-called mild breakthrough infections in the age of Omicron subvariants. So I'd argue that this post-viral long-term protracted disability time course was entirely predictable from what we already knew from long SARS in 2003 to 2004. This is from a paper that was written by John Patkai, who was the clinical lead treating the University of Toronto long SARS patients in 2003, 2004. And I'll belabor this and actually read it out because it is so sobering and salutary and painful, and ought to inform our efforts to do better for treatment of people with long COVID. None of our 50 patients got their old life back with time and treatment. Some were never able to return to work. And a reminder, this is 20 years later. Some had a trial of return to work and failed. Some had a trial of return to modified work, which then failed. Some had seniority to move to an easier position at work, which then failed. Some returned to being able to look after themselves completely, but could not return to work or sports. I feel pained even reading it to you, but I think that ought to motivate and galvanize us to simply use some of that brain wattage and some of those 45,000 papers that we've all published to just do so much better. And I think from the start we've had some kind of consensus that has held tight on where we think this is coming from. We pulled all this together in our version of the review of this in Nature Reviews last summer, and we talk about direct organ damage from a cytotoxic virus or from inflammation, the kind of thing that you can see in MRI. A lot of attention, quite rightly, to persistent reservoirs of virus or viral antigen, some interest in reactivation of human herpes viruses, particularly EBV, an immense amount of work on immune subset and immune inflammatory changes as a consequence of having had this virus on board. Lots of work about, I think you'll hear some of this later from in Risa's talk, about vascular endotheliitis and microclots, interest in mast cell activation, a lot of efforts to get to the bottom of post-viral autoimmunity, and a lot of interest in microbiota dysbiosis, which again, we know has a long track record in terms of being able to define metabolomic changes on immune function. So I place a lot of my emphasis when I think about this on the urgent need to get agreement on biomarkers, to open up the doors to studies in the subject, to clinical trials, to clinical care pathways, whether we're talking about serum protein measurements or transcriptomics, because across these publications, many biomarkers have been proposed. But I'd argue strongly that the lack of agreed biomarkers for diagnostics, for public health, for study recruitment, for study endpoints is a real bottleneck for getting people into clinical care, getting people into clinical trials, and most importantly, getting regulators on board for clinical trials. And it's an area where we all need to do better. So I'll whiz through some of what I think is going on in this space. So sure, we have across many studies some consensus on things like IL-6 and CRP and TNF-alpha and IL-8. So with quite simple measurements, we could get a biosignature together. Other things we could look at adding in, like good work on complement components. If you want to look further afield, great stuff on from Olink proteomics on slightly less well-known biomarkers. But if we had the will to do it, we could get together a core set of serum proteins that could be measured in any appropriately equipped hospital in the world, and could get people into those care pathways and into those clinical trials. This is an example from Felicity Liu at Imperial College, where she used Olink proteomic data to use machine learning to relate protein serum biomarkers to symptom clusters, and come up with some quite tight associations that, again, I think are really informative in this space. And that's in the UK FOSP COVID study group, which is a very large NIHR-funded cohort, where every patient who was hospitalized during that first wave in the UK was eligible to be consented into a long-term follow-up study. And obviously a very large number of them have persistent symptoms and have long COVID and are being very intensively studied. Also, lots of work on transcriptional biomarkers, where perhaps the energy hump for routine clinical use is a tiny bit higher, but some really good work recently published. I'm not sure if any of the people involved are in this meeting. I think they might be. There are opportunities here to get the job done properly. If you work in immunology, as I do, there's enormous amount of discussion and debate and polarization around a kind of working hypothesis, which says that a cause of long COVID is persistence of virus or viral antigen reservoirs, and a kind of subclause within that is, could that be driving some kind of T-cell exhaustion? And again, a great deal of work on that by ourselves and by others. And the starting point for this, I think the gold standard for this is, which brings sense to the debate, is that where groups have had the the opportunistic chance to access gut biopsies, for example, because they're seeing referrals to a gastroenterology clinic, to an IBD clinic, they find very good correlation between the people who have SARS-CoV-2 RNA in the gut mucosa and those who have long COVID symptoms. Yeah. So if we could only tie up that kind of reservoir data with more accessible blood biomarkers, we'd be in business. Okay. Because this is trying to tell us something. A related paper, one that I like very much, that some of you will have seen last summer coming out in Cell from Marianne Levy's lab, gives us a kind of working framework for relating gut persistence all the way through to long COVID symptomology. Because in that kind of magnum opus of a paper, they argue that persistent gut reservoir leads to a kind of chronic type 1 interferon signaling, and this in turn causes impaired tryptophan uptake and therefore serotonin synthesis, and this feeds into things like platelet hyperactivation and thrombocytopenia, and furthermore has a kind of direct readout in terms of impeding vagus nerve activity and hippocampal responses and memory. So I think this is a real kind of watch this space moment in terms of quite a nice joined up piece of work that begins to offer us some meaningful mechanism. We've been heavily involved in my lab in an NIHR national study, which we call WILCO, which stands for Working Out the Immunology of Long COVID, where in adults and now in a pediatric cohort, we try to relate symptom clusters to immune subsets, comprehensive autoantibody screening, autoimmune T-cell screening, and proteomics and RNA expression. So, what do I think as a professor of immunology of my sort of overview of those 45,000 papers and where on earth I think we are? I think it's difficult. I think we've got to be very careful that we don't silo ourselves into little polarized tribes where we have our favorite cherry-picked piece of data that explains a symptom that we're interested in, and somehow fail to try and look properly at the big picture. So my very personal view of this is that for at least a large subset of patients, I think it's quite compelling that long COVID is associated with a persistent reservoir, and many positive immune perturbations are downstream of this. On the other hand, I know that there are some papers that have tried to push a very extreme version of this, that therefore COVID-19 is like HIV and kind of somehow destroys adaptive immunity. And I'm afraid, even if it makes me unpopular with some people, from my reading of the data and from looking at an awful lot of data in our lab at immune responses in people who have long COVID, I don't think they're globally perturbed or globally immunosuppressed. I think these are quite nuanced changes that are actually non-trivial to find. And that's in no way to kind of diminish the functional immunological argument. It's to say it's not barn door. It's the immune system is a complex system of tens of thousands of cell types, and they're not all impaired in long COVID. Some are and some aren't. So
Dr. Altmann,
yes.
1 minute remaining.
Okay, right. We'll go on. Yep. So also finding for complement components, and some of you will have seen the work from Mike Peluso's lab, saying that there are PET correlates of that. So to sum up, This isn't just a way for immunologists to publish papers. There are potential therapeutics downstream of this. And I think the take-home message of my talk is that we now need to get our act together, knock heads together, and implement some large-scale randomized controlled trials that make use of all this knowledge and offer some real benefit for people with long COVID, because we can't afford the the 20-year timeline of disability that many people with ME/CFS have had, and that people with SARS, with long SARS had. We need to get some treatments into the clinic for these people. And I leave you perhaps having been a bit gloomy on a note of optimism, saying that immunology has a fantastic toolkit and has been one of the great success stories of molecular medicine of the last 25 years. Let's apply some of that now to long COVID and ME/CFS and do something for it. Thank you.
Thank you for your presentation, Professor Altmann. Attendees have submitted several questions for you, so I'm going to go through them one by one based on the most upvoted first. The first question is, can you get vaccinated against COVID and other diseases while you are recovering from long COVID, or could this backfire and increase or trigger new symptoms?
So my feeling is it's kind of a simple one, that COVID infection and reinfection is a risk for for accruing long COVID or exacerbating symptoms, and you're always better to boost your immunity and avoid that next COVID infection. So I always recommend to people to keep up their vaccination.
Okay, thank you. The second question from the community is, are there blood tests available outside scientific studies to shed light on what the individual immune defects caused by COVID are?
Yeah, I mean, it bears on to sort of the angst that I was expressing, I think, in those sort of penultimate slides, wasn't it? That immunologists measure thousands of things, and I get frustrated when I see people being charged very large amounts of money for private tests to measure one or two parameters out of the tens of thousands that we can measure, and coming at me with a sort of N=1 study saying, wow, this subset or that subset was a bit low. And yeah, I get frustrated that I don't want to see people taken advantage of, because I'd rather wait for us to have slightly clearer answers of what the immune perturbations are and be able to advise people properly.
Okay, thank you. Our next question is, what is the perspective for long haulers who are in more than 20 months from your point of view? Are they in it for the long term, or does science give hope for recovery at rather later stages?
I think that's the key question, isn't it? So if we don't get our act together, they're in for the same long haul as the long SARS people and ME/CFS people, and have no joy on the horizon for the next 20 years. And I think as civilized societies, as medical researchers, as medics, we can't allow that to happen, because we actually know an awful lot and have an awful lot of ideas and an awful lot of treatments. And the point I was making at the end is that if you think about the early days of COVID-19, one of the great successes was the recovery trial that took everything we knew about how to design randomized controlled trials at scale and said, we have people dying of atypical pneumonias that we hadn't really anticipated before, and we don't know what to do for them. Let's design some trials and do better. And we did. And mortality decreased rapidly, and it all became somewhat more manageable. We need to have the will to persuade policymakers to do the same thing for long COVID.
Thank you. The next question is, what are the current medicines for long COVID and ME/CFS?
Yeah, so I think there'll be many other talks in that area, talking about a lot of candidates. When I talk about the need for a recovery trial, a randomized controlled trial to look at the candidates, if you got a lot of experts in the room and put guns to their heads and said, name the top 20 drugs that you think must go into the trial, I think we'd be hard pressed to agree. I think we'd have some sort of anticoagulation in there, and some antihistamine in there, and some colchicine in there, and some specific anti-cytokine biologics. But none of those are a given and in the bag until we do the trials at scale. and prove once and for all what works. If you remember acute COVID-19 early days, there were many things that we thought were a sure thing that turned out not to be, and many that we hadn't really thought about that were quite simple that turned out to be amazing. So let's just do the trials properly.
Thank you again. And here's another question from the community. What is your view that ME, CFS, and long COVID are two or more distinct diseases that we currently group together due to shared symptoms and not biomarkers?
Yeah, I mean, it's what I said. I think that all of modern medicine is a sort of dispute, isn't it, between the kind of the lumpers and the stratifiers. We like stratified personal medicine and using our machine learning and things to work out all the different subcategories under our umbrella, and that's good and useful and informative. And it's also useful sometimes to look at common themes. And I think there's a lot to learn from the common themes between ME/CFS and long COVID. In my sort of schema, the main difference between them is that in long COVID, we generally know the sort of date and sequence of the initiating pathogen, and in ME/CFS often we don't. And apart from that, many of the downstream consequences are very similar, and there's so much to be learned by kind of cross-fertilization between the two research experiences.
Okay, I think this will be our final question for this Q&A session. This comes from the community. Does immune absorption make sense if autoantibodies have been detected?
Is that possibly a type of immune exhaustion, do you think? Well, who knows?
Could be.
Yeah, so I think immune exhaustion is one of our most sort of troubling debates that we have in the field, because we see some signal for it, but it's not a very profound signal, not least because when we look at frequencies of T cells involved in the immune response to spike, as you'd expect, they're frequencies of things like less than 0.1% of the repertoire. So it's slightly hard to see how even an exhaustion signal in those could have widespread consequences for the immune response at large. As for whether autoimmunity kind of interfaces with that, autoimmunity is complex in this debate, isn't it? Because on the one hand, we have terrific population level data saying that people who've had COVID-19 have substantially enhanced risk of subsequent diagnosis of autoimmune diseases in the following years. So there's a big thing going on. And yet when we try and tie long COVID symptomology to specific autoantibodies, it hasn't been an easy task. So I think that's a kind of work in progress.
Okay, thank you. As we only have 1 minute remaining, we'll end the Q&A now. Thank you again for your presentation, Professor Altmann. Thank you to the participants for submitting questions and upvoting them.